Hello, I'm Tim Burcham, Director of the Northeast Rice Research and Extension Center in Greenfield, Arkansas, and I'm with the University of Arkansas System, Division of Agriculture. Today I'm joined by Mr. Mike Hamilton, our Irrigation Education Specialist for the Division. Mike, welcome to the program today. You want to share a little bit about your position with the Division?
Thank you, Dr. Burcham. It's great to be here. I'm Mike Hamilton. I'm Irrigation Instructor with the University of Arkansas System Division of Agriculture Cooperative Extension Service, and I'm the Irrigation Water Management Specialist with the NRCS. Through a grant that we have with them, I help the NRCS folks and the conservation districts up and down the state with irrigation water management plans. And I do irrigation education all throughout the state.
So I know that you trained some of those NRCS folks. So what is the title of the folks that are helping our producers with irrigation?
The ones from the NRCS office are IWM Specialists, which stands for Irrigation Water Management Specialists. And they work with growers up and down the state with regards to irrigation water management plans and irrigation efficiency designs in their respective counties.
Super. Well, Mike, that's great that you're working not only in the extension side of things, but extending that education effort with the Natural Resources Conservation Service. Really appreciate your work and cooperation with NRCS there. Mike, we're here at the NERREC, as we call it, the Northeast Rice Research and Extension Center, and you've been instrumental in helping us with the design and implementation of the irrigation system here. What are some of the unique attributes here at the Northeast Rice Research and Extension Center, this particular farm, that give you a great foundation for your irrigation education program as well as demonstration projects?
Well, for me, location.
Yes, sir.
I learned that from Dr. Lou Brinkley up at ASU when I was up there. And, that reminds me of, the great relationship
Absolutely.
not only we have with NRCS, but with Arkansas State University.
Right.
We have a lot of collaborative research that we do with them here and at Judd Hill. And just having that relationship and this location is wonderful. Another reason that it's good to be up here in Northeast Arkansas is just the rice production that we have up here.
Yes, sir.
Poinsett County is the largest rice producing county in Arkansas, and sometimes Cross County just south of us, and even Lawrence County just a little northwest of us, come in second. So just the sheer acres of rice up here is phenomenal, and this soil type, this Henry silt loam, brings a whole lot of challenges.
Yes, sir.
Not only to the rice production, but soybean production as well.
Right.
So it's great that we have the facilities that we have up here.
Well, I know, and this farm, I believe when you go to the soil map, Mike, I think is right at 95% Henry silt loam. So we're certainly have a predominant soil type here as well. So in that Henry silt loam area, Mike, I know irrigation water use efficiency is a critical part of your education program. Can you share with our viewers some of the primary methodologies that can be used to improve irrigation water use efficiency? And I might add that here at the station we're west of Crowley's Ridge, and we're in the Cache River critical groundwater area, and so water use is one of the key factors that we look at from the standpoint of our education program. Can you share with us some of those methodologies that you're working with our growers on?
Yeah, one of the big things that we're doing is computerized hole selection, and the programs that we're using for that is the pipe planner program that was developed by the use of faucet program out of Missouri, NRCS.
Right.
And the pipe planner program was developed by Delta Plastics, and it basically, tells us what size holes to punch in the furrows from start to finish of a tubing run, so that we can get an efficient design, so that all the furrows kind of water out even. We're also using a rice irrigation app that Dr. Henry used to work in rice fields in MIRI, or multiple inlet rice irrigation. Some folks will call it side inlet,
right?
But I think that MIRI, multiple inlet rice irrigation, is a more descriptive term of that.
Yeah.
We're also using cover crops and surge valves so that we can get the correct amount of water in a profile. Put the correct amount of water on a field, whether it be too much infiltration or want to increase the infiltration out in the field. Surge valves and cover crops help with that considerably.
Yes, sir.
And then we're also using soil moisture sensors, and other irrigation scheduling software to help with timing of irrigation applications.
Absolutely. Well, Mike, I know you talked about surge valves there. Can you help our viewers with, what's the advantage of using surge valves in irrigation methodology?
Well, using the surge valve, there's basically two uses of a surge valve: to help get more water onto a field and down into the profile, or to limit the amount of infiltration that you're getting into a field.
Right.
So it helps you put the correct amount of water on a field. That's what a surge valve does.
Yes, sir.
It cycles back and forth on a set between two different cycles. The infiltration cycle, which is called the advance.
Right.
And then you have the soak cycle that'll get it down into the profile if needed. And if we have too much infiltration, we don't even use the soak cycle, just the advance to get it down to the bottom of the field.
Yes, sir. Well, Mike, we're standing in front of some zero grade rice here on our farm. We've got rice planted in 0 grade fields, 10th grade, 03 grade, and we probably got some rice on an 05 grade out on the highway out there as well. And you mentioned multiple inlet rice irrigation, but here on the NERREC farm, we have row rice irrigation methodology. We also have a field of what we would call conventional cascade type irrigation for rice here on the farm as well. Can you talk about these different methodologies of water movement on rice and maybe some of the advantages and disadvantages of each of those?
Yes, sir. Well, conventional irrigation in rice, we pull levees because of the contour of the land, whether it's sloping, whether it's 2 foot or 3 foot from top to bottom of the field. So we pull the levees so that we can keep a 4 to 6 inch flood on the field. Well, that's our conventional irrigation. And multiple inlet, we use the same system, but we put polypipe, lay flat tubing across each levee so that we can put water in each paddy simultaneously. So instead of having the bubble from top to bottom going down through the field, we put water in each paddy so that they will simultaneously fill up at the same time. And the big advantage of that is we can catch a rain.
Yes, sir.
We can catch a rain in any irrigation system, but if we have that big bubble, sometimes we'll get too much on the top paddies, and it'll be too much for our spills or levee gates, and we might wash out, some of the bottom levees. So with multiple inlet, we're spreading out the cold water and able to catch a rain is one of the big benefits. And we're using less water by 25% average with multiple inlet. On row rice or furrow irrigated rice, we're changing everything, and we're going basically like we're using watering corn or soybeans or milo or cotton, is we're watering it down the furrows. We're laying tubing down the side of the field and watering each furrow independently. And the advantage of that is we're not pulling the levees, we're not tearing down the levees, we're not putting in spills. We're able to transition from one crop to the next seamlessly with very little field work. And with the labor situation we got going on right now, row rice is really catching on fast.
Well, I know the row rice production, probably is maybe more advantageous in some of the tighter soils, maybe say Mississippi County, for example, where a lot of clay-based soils here. On the Henry Silt loams, we've got a fragipan not too deep below the soil here, probably 2 feet, Mike. And so, but you think there's still some opportunity for row rice even in regions like here in Poinsett County where we're on these Henry Silt loam soils?
Oh yeah, definitely. We can hold water like a jug on a lot of these fields up
Yes,
here
sir.
in Poinsett County.
Yes, sir.
And that's wonderful for rice, but the big benefit to using furrow rice or row rice is that with the slope that we have out there, we've got fields just within 4 or 5 miles of here that in a quarter mile drop 11 foot.
Wow.
From the top of the field to the bottom.
Yeah.
And you could just imagine the levees stacked in there, so that we can keep that 4 to 6 inch flood.
Right.
And that's a big advantage of row rice, is that we take those levees out from going sideways down that fall, and we're putting them on rows, so all the levees are going downhill. And you know, we're actually getting more acres of rice out in some of these fields.
Yes, sir.
You know, there's disadvantages and advantages to every system, but you know, on those fields it's got some steep elevation changes. Row rice is really hitting a home run on some of these fields. But we also want to watch our furrow spacings out there. You know, there's a lot of education that needs to be done in row rice.
Yes, sir.
So I'm glad we're doing the research and glad we have that here on the station.
Well, you know, this is, of course, we did a demonstration block of row rice that's out on our frontage out there on Highway 1. Mike, and your comment about the bed building, that was one of the challenges that we had. We probably built our beds a little bit too shallow and had some issues with water movement that we had to correct mechanically, but really looking like a good crop. So I certainly would agree with you on our, you know, building our beds, and that's going to be something that's really critical going forward, particularly for row rice in this area. Mike, I know you've implemented soil moisture sensors. You mentioned that just a little while ago, and if you would just share with us a little bit about soil moisture sensors. I know you've got them implemented on the soybean fields here at the farm. Can you talk about soil moisture sensors and, you know, why they're a critical part of water saving activity and really an economic benefit to our producers?
You know, it's all goes back to irrigation scheduling. You know, we've got a lot of growers that irrigate every Monday morning, regardless of what crop it is or what stage of growth that crop is in.
Right.
Well, by using soil moisture sensors, we're able to see what an irrigation event does. You know, how far down in the profile that water goes. The same is true for a rainfall event.
Right.
You know, we get to see what a half-inch rain, how much that infiltrates down into the profile, how much a 2-inch rain infiltrates, whether it seals over and goes down, you know, down the furrow to the ditch. You know, we get to see all of that by using the soil moisture sensors. We recommend them at 6, 12, 18, and 30-inch depths so that we can really monitor the depths that the water's getting and the depth of our root system. You know, you get to watch that root development and where we're using water by using the soil moisture sensor. So it's really a game changer when it comes to irrigation scheduling.
Well, Mike, I know when you implemented that out here, you provided me with some login credentials, so you're able to actually monitor the soil moisture remotely as well. So that's also a game changer.
Oh yeah, that's one of the things that growers really like about it. You know, you can put sensors out in the field and go monitor them with a handheld unit.
Yes, sir.
And save quite a bit of money, but it's worth a little extra money to be able to log in and look at that anywhere you're at.
Right.
Whether you're over in Fayetteville watching the hogs or even over Mississippi State watching them dogs.
Yeah, absolutely. Well, Mike, also one of the things that you've worked hard with us on is providing some RTK-based imagery for the farm. And as recently as last week, you flew all of our research fields so that I could put into our GIS program the outline of each of the plots that we have. I know Dr. Hartke's work, those other researchers, USDA-ARS back here in the back. So can you talk a little bit about how your use of RTK drone imagery is, and how you're using that in your irrigation program, and I guess help our viewers understand what's the difference between RTK-based drone flights versus just a standard drone that's just taking an image or a picture?
Well, I'm not going to get into all the science of it, but RTK is real-time kinetics, and it's instead of using just the imagery that growers are using and getting a still picture of the field, I'm able to use the RTK. I put up a base station, and just like your land levelers and surveyors, I can get an elevation reading by flying that drone over the field, whether it's muddy or dry out there. I can fly that drone over the field and get elevation data anywhere out in the field I want to.
Right.
And it's within 1/10 of an inch.
Right.
It's not sub-inch, or excuse me, it's within
1/10 of a foot. Right.
Which is not less than an inch, but just a little bit bigger than an inch.
Yeah.
And on a tubing run where that tubing is going up and down hill, that's very important on an irrigation design, because a 1/2 inch hole may give you 3.5 gallons of water at one side, but depending on that slope and elevation change, it may give you 7 gallons of water at a different spot.
Absolutely.
So it's really, really important.
Yeah, so you're using that to do elevations for polypipe runs, and I know you've got an implementation. You're also, I know, promoting like open-ended pipes for your polypipe layout. What are some advantages of using that open end versus tying a knot in the polypipe, and where might be some places that would be advantageous to use, and why you're recommending that?
Well, on a hillside,
Yes, sir.
where we've got the polypipe that's falling downhill from the riser, the water source, to the end of the field, where's the pressure? It's down at the bottom. So if you put a knot down there and we have any surging on that well, where we get more or less water out of it, that knot's not going to hold up.
Yeah.
But if we put an open end down there, whether it going over a barrel or using a piece of pipe like we've got in the here on this farm,
yes, sir.
That we can burp out a little air, and that water's got somewhere to go.
Yeah.
Instead of rupturing that knot.
Yeah.
And the same thing is true. We'll put an inline tee up on the top of a field where we've got too much pressure at the well.
Right.
We could put an inline tee up there and build it up to, depending on what tubing we're using and the pipe planter design. But you can build that up to 2.5 foot and basically feel safe that your tubing is not going to rupture.
Yeah.
There's a lot of math that goes into it, and I would really recommend everybody get those elevation runs from top to bottom. But it's a game changer.
So Mike, also on your RTK imagery, I know it's not just the images that you're doing, but your drones are equipped with some other sensor technologies that you're utilizing on this farm, as well as the Judd Hill location, some of the other demonstrations. Can you talk about some of the other sensor payloads that you're using on your drone?
Yeah, well, just a regular sensor or camera.
Yes, sir.
That's on the drone. Even the ones the growers have, they can fly it over a field and map the field, and use QGIS or ArcMap or ArcPro, so that they can measure the acres of every paddy and do a multiple inlet design and start off on the front end with the acres correct in that design. Right. So that they have the right number of holes and get the right amount of water on the front end. Yeah. You're going to have to adjust that throughout the season initially. But once you get it set, you're not adjusting it anymore. And using that technology has been pretty nice. Yeah. We're also using some thermal sensors, which I'm using the Altum, which I can do NDVIs and thermal images of a field. Right. So that you can actually look at the health of the crop and see some bad areas out there. Just flew it for Dr. Fred Borden over on some cotton plots over at Judd Hill. Yes, sir. And it's amazing that we can see the verticillium wilt showing up in those cotton fields and the transition from one week to the next, right, and how severe it's getting just by looking at those aerial images. Yeah. Even the RGB, which is the true color image, right, you can really see that from those drone images. Well, I know those thermal images you shared, and we'll share those with our viewers here, but really remarkable difference on Dr. Borland's plots over there on those thermal images, and so a lot of information. I know information and processing the information is still a laborious task. You were sharing with me that RTK imagery might take your computer 8 hours to stitch together these images. Thermal imaging, yes, sir, and stuff. It's really time consuming. Yeah. But there's some software coming out that'll help that bottleneck. But we're not going back in time. Right. Everybody's got a smartphone and a lot of people are getting drones out in the fields, and what we're using them for cut sheets now. Yes, sir. To help with land leveling, for drainage of a field. The accuracy is just amazing, and we're not going back in time. They're going to be here. I know Richard Pickett has come out, and he's with P&P Consulting and working on his graduate degree at Arkansas State University, and is using our farm to do some of his research work, and he's helped us with some of his fixed wing imagery as well. And I know we have digital elevation maps that are down to the square inch for this entire farm, and so the technology, Mike, is just really revolutionary, and it's a game changer going forward in everything from the standpoint of elevation data on our farms. It's not going back. Well, Dr. Burcham, thank you very much for the invitation here to the Rice Research Station in Northeast Arkansas. I really appreciate the invite. Yes, sir. I really appreciate your leadership here on the farm, and let me help out on the farm from time to time. Which brings me to what we got behind us here, and some questions that I got for you.
Sure.
On the rye station.
Yeah.
Well, I know there's irrigation's a four-letter word sometimes in my world, and because we've went through a lot of trials and tribulations. So what good, bad, and ugly things have happened to you here on the farm?
Well, Mike, that's a great question, and we're here at our relift back here on the Languille River, and that's one of the design aspects that we had put in. This particular setup lets us pump water from the river directly into the irrigation system by opening that valve, and then we can open this other valve and also pump water into our reservoir here. And Mike, we made it all the way through this irrigation system using nothing but surface water. It was a little bit iffy. You're talking about trials. There was a period where the river was down that we were a little bit concerned, but we always had water in the reservoir. We are going to be drilling a well for the irrigation system this fall, and so we're excited to have that. We've already got the three-phase power routed for that. While this particular setup right now, we ran diesel this year, but we've already got the three-phase power here. We have a Yaskawa donated VFD that will be set up here as well. So this particular setup was the foundation for our irrigation system, because it moved all the water into the reservoir. From the reservoir this year, we used gravity flow extensively with no power whatsoever when we had the reservoir fully at 10 foot deep. We also have a booster pump that also has a Yaskawa VFD on it, so we could vary the flow there. Today they're finishing watering beans, for example, over here on the west side of Dana Lane, and we're able to generate over 3,000 GPM, so they're actually watering beans in a single set today of 100 acres and have adequate flow for that. You know, from a trials standpoint, we've had some issues with keeping some of our risers intact. We had some connection issues, and as you know, when you're moving a column of water through 15-inch line that's a mile long, that's a lot of weight, and so you need to have those valves opened up, and we've had some learning experiments there, but overall we've been really thrilled with the design that's allowed us to move water to any location on the farm and really have effective flow all over the farm. Over here on the south side of the reservoir, we put in a parallel flow network that allows us to pump to the southern portion of the farm as well as to the eastern side of the farm simultaneously, and that gave us another great avenue and some versatility with regard to our water.
Right. There's a lot of farms up and down the state that have everything tied together just like we have here on the station. And you know, this kind of research and working with that kind of system can really help educate some growers with some problems that we've got out in the real world. Yeah,
and you know, Mike, for this being a research and demonstration farm, the ability to have direct river water coming straight out of the river, coming out of our reservoir, as well as groundwater to any location on the farm with the irrigation network design, really gives us some great opportunities from a research standpoint, because we could look at cold water impact on fields and those kinds of things. So the work that you did, Dr. Henry helped us with this as well, putting together this irrigation system that incorporated a lot of the network that was here on the farm, but then has expanded that greatly, has just been a good experience, and we're really excited about the capacity that we have here to get water on any field on the farm.
You know, Dr. Burcham, that says a lot, and you know, that's the reason we're doing the work is for the growers. You know, that's the bottom line, and all the different entities that we have helping out and the teamwork. You know, it's all about helping the producers is the end goal.
Yeah, Mike, and I just want to tell you, I'm so encouraged, you know, with the outpouring of support that we've had from our private industries as well for the irrigation system here. You know, we have C-Metrics have donated flow meters for our irrigation system. Micrometer has donated flow meters. Swish Inc. out of Coldwater, Mississippi built all of our portable flow meters that are equipped with the C-Metrics flow meters, so 10 of those. And they did all of the the aluminum welding to put those together. I mentioned in my discussion about the irrigation system, Yoshikawa came forward with 2 VFD drives for our motors, and so that's a tremendous thing. And then I'd be remiss if I didn't mention Richard Pickett of P&P Consulting. I know he's worked with you really in lockstep, and Richard has come out here and donated his time and his components of his imagery program to help us here at the farm as well. So I've really thank you for what you've been able to do for us, not only from the irrigation design, but also for the imagery. And of course, Richard has been helping us with that as well, providing some of that high resolution imagery. So we want to thank you. We want to thank all of our growers for joining us today. And I'm Tim Burcham, Director of the Northeast Rice Research and Extension Center with the University of Arkansas System, Division of Agriculture, and a special thanks to my guest today, Mr. Mike Hamilton.
Thank you.